In this video, we'll be using the formal definition of limit, sometimes called the epsilon delta definition, to verify the limit of a function. Right here, you'll see the formal definition written out with symbols. Let me read that in case you're not familiar with some of the symbols. The limit as x approaches c of f of x is equal to L means for every epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus c, which is less than delta, then the absolute value of f of x minus L is less than epsilon. Now the problem that we'll be doing is to verify the limit of f of x equals 7x minus 3 as x approaches 2. The first thing we'll need to do is actually find the limit. So we'll want to find the limit as x approaches 2 of 7x minus 3. Now we can do this with just direct substitution. If we put 2 into this function for x, we see that 7 times 2 minus 3, so that's 14 minus 3, which is 11. So we see that the limit as x approaches 2 of f of x is equal to 11. So we're going to verify that limit. Now if we compare this information that we're working with to the formal definition of limit, you can see that f of x is this expression right here. So let me write that. F of x is 7x minus 3. We can also see that c is 2, because x approaches 2. So c is 2. And L is 11. So we're going to use this information in our formal definition. We'll start with this right here. So we have 0 is less than absolute value of x minus c is less than delta. Then absolute value of f of x minus L is less than epsilon. So let's put the stuff in that we know. We know that c is 2. So we have 0 is less than absolute value of x minus 2 is less than delta. And here we have absolute value f of x is 7x minus 3. And then subtract 11 is less than epsilon. So we need to make a connection here. So let's take this absolute value and work with that. That is 7x minus 14. And that is less than epsilon, sorry. Now we can factor out a 7. So if we factor a 7 out of this term, we're left with x. And factor 7 out of this term, we're left with 2. and that's less than epsilon. Now notice that we have an absolute value of x minus 2 here, and we have an absolute value of x minus 2 here. So let's divide both sides by 7. These will cancel, and I have absolute value of x minus 2 is less than epsilon divided by 7. So that means then, in order for our limit to be equal to 11 and our distance from x to our constant c to be less than delta, we need to choose delta to equal epsilon divided by 7.